All right, how's it going, guys? I wanted to go over the cut list assignment for this week. You were given a bunch of drawings, and you have to determine a cut list for all of them. I figured I'd just go ahead and go through each paper, even though you might have only been assigned to build one of these items. I still want to go over all of them. So the first page is this window flat, right? So this is, the window, and then the rest of it gets covered. So if we look at the words on the top, window flat, build with 1x3 and skin with Luan or MDF, then route out the middle window. All right, so we know that we're building with 1x3, and it's safe to assume that we're building with, it where the material is on edge, right? So a Hollywood flat instead of a theatrical flat, which is a couple assignments down. Right, so this would be the theatrical flat where the material is on face. All right, so we'll start with the rails, right? The top rail, bottom rail, pretty easy. We need 2 of those at 2 foot 0 inches. All right, now let's go on to the stiles, this one and this one. So the total height of the flat is 3 feet 11 minus the top rail minus the bottom rail, right, which totals 1.5 inches. So 3 feet 11 minus 1.5 inches gives us 3 feet 9.5. All right. So now we have this one and this one. So creating the window, we have these like inner stiles or vertical toggles. We have 2 of those. And looking at the dimension over here, right, we can see it's from this point to that point. So there's no math, luckily. So 2 at 1 foot 11 and a quarter. All right, the next 2, we have this toggle and this toggle. All right, so the total width is 2 feet minus the 3/4 here minus the 3/4 here. Gives us 1.5 inches, so 2 feet minus 1.5 inches. All right. Now going over the sort of other dimensions that are given, you see that these dimensions here, this is just for placement, right? So we don't need these dimensions to do any math, right? This one and this one. But it will help us when we build the flat, right? Because we're going to need to know where to place everything. Same thing goes for this 5.5 dimension, right? It says the outer side, or I guess the inner side of this framing member is from here 5.5 inches over. Typically, if it looks sort of symmetrical on the other side of the flat and only one dimension is given, it's safe to assume that it's the same thing on this side, right? If it was different, there'd be more dimensions for this, right? So that's the cut list, and then yeah. All right, moving on to the staircase. So the staircase, it's a little bit tricky to see in this sort of isometric view, but looking at it, on the side views, you have the plywood carriage, right? You have the 2 steps, and then you have the runners or the supports, right? So these rectangles right here, right, where it says 1x3 supports. right? There are no risers in this staircase. There's just the part where you step. So let's break this down. So for the plywood, right, we're looking at 2 feet. And then we know that this is 3/4 ply. So 1'4" minus 3/4, 1 foot 3 1/4. So to build this staircase, we're gonna need, let's see, 3/4 ply, 2 at 2 feet by 1 foot 3 1/4. Right. So that's a good way to write it. You could write parentheses, just so you know the material. We also need plywood for the treads, right? The part where you step. So same thing, 3/4 ply. We need 2 of those that are, we know that the total is 2 feet this way, right? Pretty safe to assume it's a split, right? So 1 foot and 1 foot. So let's see, 1 foot by, and then the total width of the staircase is 2 feet. So 1 foot by 2 foot. Then for the 1x3 supports, you're looking at 1, 2, 3, 4, 5, 6. 6. And the total is 2 feet. So there you go. That's for the staircase. Yeah. All right. This one's pretty tricky. It's a little bit difficult to write out. But you'll sort of, usually if you're the one writing it, you're also the one cutting the material, so you could sort of have a better understanding of what's going on. Let's see, all the dimensions are here. We have angles now, which is something we haven't talked about in class. But when you have a, we'll call this a straight vertical, right? So a straight vertical meeting an angled piece, right? Where both pieces are angled and you have 73 degrees. When you use the miter saw, right, there's a little dial that you could adjust on the front. And what you're supposed to do, because the saw cuts at 90, it doesn't actually cut at 0. So what you're going to have to do is take 90, subtract 73, you're going to get 17 degrees. So when you go over to the miter saw, you're going to move the blade over to 17-degree position. And that'll give you the angle, you know, to make this cut. All right. So we'll do the bottom rail as part A. So 1 foot 11, pretty easy. The sort of toggle at part B, right? So you have a thickness here, 1 foot 11 minus 2 thicknesses gives us 1 foot 9 1/2. All right, so the rest have angles. And if we look at, say, this one in particular, right? You see there's a long point and a short point, right? So, you know, if you take an angled piece, you know, one edge is longer than the other edge. So we know that This thickness here is 3/4. It's safe to assume that the thickness here is also 3/4. It is slightly more because of the angle, but it's safe to assume in this case. Usually if it's not safe to assume, the draftsperson would, make the mark from the bottom of the flat to the top point. But since it's given the full height, pretty safe to assume that, this thickness is 3/4. Right? So let's see. 3 feet 11 minus bottom thickness and top thickness gives us 3 feet 9.5. So 3 feet 9.5 inches. And then usually, let's see if I can find this symbol. You'll do an angle symbol, right? And then I'll do LS, right? So that means long side. You could do LP for long point, and replace the L with an S for the short side. So angle LS 17. All right, you could add a little tick mark, sort of 17 degrees, if you want. You don't have to. Usually it's pretty understandable. But yeah, so I'll sort of repeat this piece again. 3 feet 9.5, long side 17-degree cut. Right. So the way that I would recommend cutting this is actually cutting the 17 degrees, right? And then measuring from that point down to the straight side, right? It's easier to make the straight cut as opposed to the angle cut, right? So if you start with the angle cut and then measure, then you could just finish the piece off with a straight cut. So that makes it pretty easy. All right. Let's see. So going to this piece. In this case, the dimensions actually provided to us, right? So 3 feet 2 and 11/16 with an angle, right? And it's also 17 degrees, right? But it's just we do 107 minus 90, right? So that's also 17. Usually on a flat where it's two verticals and an angled side, the angle used for this is the same thing for this, right? There's not like, different angles going on, which, once you start cutting angled flats and angled pieces, this sort of makes a little bit more sense. All right, so angled long side, 17 degrees. All right, and then the last piece, all right, so the dimension is given, but it's given from the long point to the short point. So, this could be written in a couple different ways. You could do short to short, long to short, or long to long. The good thing is though, no matter how you orient this piece, it's the same dimensions. So as long as you are marking it correctly in terms of long to short, in this scenario, then you should be good. All right, so 2 feet. A 0 and a 16th, right? So you see I have a couple of, I've added some extra letters here, right? So angle, and then it says LS-SS. So long side to short side, and then 17 degrees. And then I'll usually either put like another sort of annotation, like another little caret, or I'll do, BS for both sides, right? Which will tell me that both sides get cut. But like I said, usually if you're the one making the cut list, the one building the flat, you're the one making the cut list as well. So usually you just got to write it in a way that makes sense to you. So yeah, all right, moving on. So here we have a platform. This particular platform is built with 1x6, which is actually more common than you think. 2x4 is a sort of standard material to build platforms with. It's pretty cheap, it's pretty strong, but usually 2x4 is considered like a construction material. So it's got rounded edges, it's not as straight. You could buy premium 2x4, but that is a premium cost. 1x6 is good for a couple reasons. One, it has a nice like squared edge, so it looks a little bit nicer. The other good thing about it is once you've built the platform and put the plywood on, and if you were to put this on the ground, it'll give you a total height of 6.25, which is a average step height, right? So you could actually like stack platforms and create a staircase that way, right? So you don't need additional legs or stud walls or anything like that. So it is, it does have an advantage. Right, and it says lid with 3/4 or 5/8. And it, most of the time it's going to be 3/4. For our class, you could do 5/8. It's not ideal, but it is acceptable. And given the size of the platform, you can only have 2 people standing on this at once. Given the strength of 5/8, it'll be just fine. All right. So we know that we're building with 1x6. 1x6 has a thickness of 3/4 and a face width of 5.5, right? Indicated here at the bottom. We're just focusing on the 3/4 thickness right now. So let's see, we need one of these, which is the same as this, right? So this would be our rails. Even though the drawing is sort of on its side, you see how this piece goes full width, all right? So we'd still call it a rail. So we need 2 rails. So we do 1x6, 2 at 2 feet. All right, pretty simple. For B, we'll do the long ones, right, or the stiles. So 1x6, 2 at 4 feet minus 3/4 here and 3/4 here, right? So 1.5 inches. So it'll give us 2 at 3 feet, 10.5 inches, right? Then for the middle toggle, right? Thickness here, 2 feet minus 2 thicknesses gives us 1x6, 1 at 1 foot, 10.5 inches. Right, so there you go. It's the 1x6. For D, would just be the plywood, right? So 3/4 ply. At 2 feet by 4 feet. Cool. All right, moving on. This is a theatrical flat. So this is where the material is on face, right? So it's having the flat be skinnier as opposed to thicker, right? And usually, it'll be annotated in a little bit different fashion, right? So you can see here it says 2.5, right? It's a reminder that we're building a theatrical flat. And the clarification is here as well. So let's see, total height 3'11", total width 1'11". So let's start with the rails, right? 2 at 1'11". Moving on to the stiles, 3'11" minus 1/3 here, and 1/3 here. So right, just a reminder, the width of a 1/3 is 2.5. So 2.5 plus 2.5 is 5. 3'11" minus 5 inches will give us 3'6". All right. So 2 at 3'6". Then for the middle, the toggle, right? Sometimes you might see these at an angle, right? So you'd see like a V pattern. But you could see just the one, center toggle is also common. So 1'11" minus 2.5 minus 2.5, right? 1'11" minus 5 gives you 1'6". All right. So there's 2 more spaces. They're not drawn here, but it is implied, right? And it is annotated here, add corners and braces as needed. So whenever you build a theatrical flat, you need an additional material to go and join these corners, right? And then you need an additional piece to join the toggle to the outer frame. And these are just 1/4-inch plywood pieces, right? So for the corners, you need 8x8 triangles, right? So 8-inch by 8-inch triangles, right? 1/4 ply. You can use Luan, although it is not quote unquote professional or industry standard. But you probably could get away with it. I've gotten away with it for quite some time. It is by no means what you should use, right? Luan doesn't have that alternating grain pattern like plywood, so Luan will just rip, right? And this is something I can demonstrate in class. It'll just separate and snap. But depending on what you're doing, it could work. For here, we need some rectangles, right? 2.5 by 8. I should indicate how many pieces we need over here. All right, so for the straps, right, the pieces that go here, we just need 2 of those, but those are 2.5 inches by 8 inches. And I'll just put rec, right, for rectangle. Also 1/4 ply, 2 pieces. All right, usually these plywood pieces are pre-cut, like the shop has like a bin ready to go. But sometimes, you need to cut more. And for this exercise, if you are building this flat, you're going to have to cut those pieces. You're not going to use what the school has. So yeah, that's these are the exercises. Hope it makes sense. Cool.